Hello guys, welcome to Edu-Malanga. Edu-Malanga gives you the inside scoop on matric mathematics in South Africa. We have tutorial videos that we offer for absolutely free. We're just going to develop them and dump them on our YouTube page. Subscribe, use them, and hopefully they'll help you do well with your matric math. In today's edition of Matric Math, we are working through trigonometry. It's the last unit from term 1 and we are still revising grade 11 work. This will be the last video where we do grade 11 revision though. And today we are going to do graphs, co-ratios and identities. Let's start by doing the graphs for sine, cosine and tan theta. We'll start with the graph of sine theta. So on this page we'll have our graph of sine theta. And we're going to use this table in particular to come up with the graph. This is the table of the trig special angles. We derived these special angles in the previous video. You have to memorize them, guys. Sometimes you get asked questions that require you to simplify trig ratios and you have to use the special angles. So you have to know when someone says, what's sine of 45 degrees? That is root 2 over 2. If you don't understand or know them, go to the previous video and watch that. You'll be able to understand. Let's continue with the graph of sine theta. So we're going to draw sine theta, and from the table of special angles we can very quickly read for 0 to 90 degrees. So let's plot these values. Sine of 0 degrees is 0. So on this graph, this is where our 0 degrees is, and this is our 0. Sine of 0 is 0. Let's move to 90. We're going to do the other ones in between, maybe. So sine of 90 degrees is 1. Let's come and draw it. 90 degrees, we go all the way up to 1. So about here, yes. And we need to do sine of 180 degrees, sine of 270 degrees, and sine of 360 degrees. So let's check those. Sine of 180 degrees. Guys, you need your calculator to check this. Put this into your calculator and make sure that your calculator is set to degrees, and you will find that it's equal to 0. So we come back to our graph, and at 180 we found that it was 0. Let's check for 270 now. Sine of 270 degrees, what's that equal to? Negative 1. Come back to the graph. At 270 degrees you go to minus 1. So somewhere over here. And the last one is the sine of 360 degrees. And that is equal to 0 and 0. So we're looking at a zigzag that looks like this. Yes, let's just come back to our table and maybe pick one value. Sine of 30 degrees is equal to 1/2. So we'll put that in the graph. Halfway would have been 45. 30 degrees is slightly less than that, and we go to half. So let's draw the graph. Our graph is looking like this. It's growing this way, yes. And then at 180 degrees it's gone to 0, so it should come back and go down to 270 and come back at 360 to 0. So this is the graph of sine of theta. What we can read on this graph is that the amplitude, which is this length over here, is equal to 1. The amplitude of a graph is the displacement that it has to the top of the crest or the bottom of a trough, which would be here. And we can tell that this is 1 and this is also equal to 1 again. So that's the amplitude of our graph. And this graph will keep on repeating itself every 360 degrees, and so we call 360 the wavelength of this graph. Let's write these features down. Amplitude is equal to 1 and wavelength is equal to 360 degrees. So this is the sine graph and its properties. Let's move on now and do the cosine graph, cos of theta, and this will be the graph of that. Let's come back to this table. The cosine of 0 degrees was equal to 1. So with cosine we're starting at 1 for 0 degrees. And let's look at 90. At 90 degrees we have 0. So let's draw that. 90 degrees is 0. Let's check for 180. Cos 180 degrees is equal to, put this into your calculator, and the answer is going to be -1. Let's draw that our graph. Our 180 came to -1. So down here, yes. Let's check now. Cos of 270 degrees, that's equal to 0. We'll draw that on the graph again. So we have 0. And the last one we will have is cos of 360 degrees. And that's going to equal to 1 again. And it comes to 1. So let's draw this graph from this. We can see it's looking something like this. Went down to -1 at 180, 0 at 270, and the last one is 1 at 360. Sorry, my sketch is a little bit crooked. It's more of a smooth wave than it is this crooked line that I've drawn, but we can see the important features. Let's again check the amplitude of our graph. Again, our amplitude is equal to 1. We can quickly see at 1 it stops, and at -1 it turns again. This is our crest and this is our trough, and our wavelength is also the same. It's 360 degrees. So the amplitude of the cosine and the sine graph are exactly the same, as well as the wavelengths. Let's do the last graph now, and this will be the graph of tan theta. We'll again start by looking at our table of special angles. Tan of 0 degrees is equal to 0. We'll plot that on our graph. Tan of 0 is equal to 0. It's over here. Let's look at tan of 90. Tan of 90 degrees is undefined. When you're drawing a graph and you put a value into your calculator and the calculator returns an error, it means that that specific value is undefined, and in terms of your graph it is an asymptote. So the graph of tan theta will have an asymptote at 90 degrees. Let's draw the asymptote. Our asymptote is here. It's a vertical line at 90 degrees because tan of 90 is undefined. Let's check now the tangent of 180 degrees. We're going to put into our calculator tan of 180 degrees, and we're going to find that it's equal to 0 again. So we come to 180 and we have 0. Let's check the tangent of 270 degrees. We'll put this into our calculators again, and we're going to find undefined again. So 270 degrees is also an asymptote. Let me draw that line as well. The last value for us to check is the tan of 360 degrees. Tan of 360 degrees. If we put that into our calculator, we'll find another 0. So all we have is zeros and asymptotes. That means we need to define more values. Let's start over here between 0 degrees and 90 degrees. Let's go halfway and pick 45 degrees. We can check 45 degrees on this table. The tangent of 45 degrees is equal to 1. Let's draw it in our graph at 45 degrees, which is about halfway. You're going to have 1. And let's check a value close to the 90 degrees, maybe 80 degrees. So we'll put into our calculators tan of 80 degrees, and we're going to find it's equal to 5.7. So the values are growing. 5.7 will be high up somewhere there. So what we can see is that this graph is doing this, and it's growing on this side. Let's come now between 90 and 180. Again, we'll choose the halfway point, and that is 135 degrees. So we'll put into our calculators the tangent of 135 degrees, and we find that it's equal to -1. So at this point, about halfway there, we go to -1 on our tan graph. Okay, let's pick a value close to here again. So we'll pick 100 degrees. The tangent of 100 degrees is equal to minus 5.7, which is somewhere down there. So here on tan, the values are doing this and getting smaller about the asymptote. Let's move to this side. Between 180 degrees and 270 degrees, the halfway point is at 225 degrees. And if we put into our calculators tan of 225 degrees, we will find that the answer is equal to 1. So again, we're going to 1, which is about here. 1. It's starting to look like history is repeating itself. Let's check 260 degrees. The tangent of 260 degrees is equal to 5.7. Yes, history is repeating itself. So the graph will grow to this. Because we've watched history repeat itself, guys, we can make predictions. So by my predictions, between 270 and 360 degrees, the halfway point we can calculate, that's equal to 315 degrees. From watching this pattern over here, my prediction is that at 315 degrees, tan is equal to negative 1. Let's check it by putting it into our calculators. Tan of 315 degrees is equal to negative 1, like I predicted. That's what math is about. So at this point, we're going to have negative 1. And again, I'm predicting that at 280, so if we check the tan of 280 degrees, we will find it's equal to negative 5.7. Put it into your calculator to make sure. Don't just trust me. Yes, check for yourself. But I hope you can see how I predicted. Minus 5.7. So this graph will start here and will stop at 360. And this is the graph of tan theta. This graph is different from the other graphs. These ones were a wave that moves like this and keeps on moving. With the tan graph, you go here and you have an asymptote, and then you start and you go again. Because it's not a wave, we're not going to have a wavelength. We're going to call this a period. And this is when the graph repeats itself. We can see that this graph repeats itself every 180 degrees. So the next asymptote will be at 270 plus 180. It'll be at 450. So the period of the tan graph is equal to 180 degrees. Guys, period basically is another word for wavelength. So over here we can say period or wavelength. That's the same. And this is the distance that the graph takes to start at a particular point, go, and return to that exact point where it started. That we call the period or the wavelength of the graph. Maybe we should just refer to all of it as period. It'll make it easier for you to always remember, especially because this definition is also applicable to the tan graph. So let's use the definition of period for these graphs. And these are all the graphs of sine, cosine, and tangent. I hope you know how to draw them and that you can easily recognize them. Let's move on now and look at co-ratios. Co-ratios come from the word complementary. So co-ratios is short for complementary ratios. And how does it work? When we speak about complementary angles, we're saying that they add to 90 degrees. Remember this, guys. When two angles are complementary, when you sum them up, they add to 90 degrees. And there's something special that happens with these angles. It's again shown on this table over here. The cosine of 30 degrees is equal to the sine of 60 degrees. And the sine of 30 degrees is equal to the cosine of 60 degrees. This happens because of co-ratios, and we can illustrate it using the co-ratio relationships. Let me write it down. The cosine of 90 degrees minus theta is equal to the sine of that theta, and the sine of 90 degrees minus theta is equal to the cosine of theta. We can check this using the table. Say for example our theta is equal to 30 degrees. So the cosine of 90 degrees minus theta, 90 degrees minus theta will equal to 60 degrees. Let's come to the table. The cosine of 60 degrees, which is 90 degrees minus theta, is equal to the cosine of the theta, which is 30 degrees. And that's what co-ratios help us to understand. You have to remember them because they help you simplify your trig equations. And there's another two co-ratios that we must define, and it's that cosine of 90 degrees plus theta, that's equal to minus sine theta. And the sine of 90 degrees plus theta is equal to cos of theta. Remember these guys, when you're working with trig equations, you can use them to simplify. If you see an equation with cos of 90 plus or minus, you can simplify it to something. That's what co-ratios help you to do. And the last thing we will revise today are trig identities. I'm not going to derive them. I'm just going to write them down because it's important that we know them. They also help us to work with trig equations. And the first identity we've looked at in previous videos, it's that the tangent of theta is equal to sine of theta divided by the cosine of theta. This is identity number 1. And the last identity is that the sine squared of theta plus the cosine squared of theta is equal to 1. You should not be seeing them for the first time because we're doing grade 11 revision. If you are, please spend some time researching how to derive them and making sure that you understand them, and also remember them so you can simplify and solve trig equations. You'll be able to see how to use all of these, the identities and the co-ratios, in the next video where we're going to do examples on trig. We've reached the end of this tutorial video. I hope you understood. If you have any questions, please leave them for me in the comments section. Join us again next time where we will be doing grade 11 trig examples.